Hi, in this tutorial I will give an overview of Raspberry Pi Pico. So here you see the contents of this tutorial. First a short introduction, then an introduction to the Raspberry Pi Pico hardware, then the Thonny Python editor, which is the recommended Python editor to use in combination with Raspberry Pi Pico. Of course you can also use other Python editors, but Thonny is simple to use, and it's also ready for use with the Raspberry Pi Pico hardware. Then an introduction to MicroPython. MicroPython is a small version of ordinary Python which is used on microcontrollers like the Raspberry Pi Pico. Then I will provide some Python examples. First I will use the LED that is on board on the Raspberry Pi hardware. Then I will connect an external LED. Then we will use pulse width modulation, and then I will connect and use and read data from an external temperature sensor. In this tutorial I will use a temperature sensor called temp36. Then I will show you how you can run the Pico without having a PC connected, and then finally a short introduction to something called Pico Zero. So let's start with a short introduction. So in this tutorial we are going to introduce the Raspberry Pi Pico hardware, or the Raspberry Pi Pico microcontroller. So Raspberry Pi Pico is a downscaled version of the original Raspberry Pi, and you could say Raspberry Pi Pico is more comparable with the Arduino hardware. You also need to use a downscaled version of Python, which is called MicroPython. Of course you can also use other programming languages like C, C++, but MicroPython is the recommended programming environment for the Raspberry Pi Pico. So in this tutorial, of course you need a Raspberry Pi Pico. You need a micro USB cable in order to connect the Raspberry Pi Pico to your PC. Of course you need a PC, and then I recommend the Thonny Python editor, which you can download and install for free. You need a breadboard, and you need some electronic components like LEDs, resistors, jumper wires, etc. And also we are going to use this temperature sensor, this temp36, in this tutorial. So let's give a short overview of the Raspberry Pi Pico hardware. So the Raspberry Pi Pico comes in 4 different types. You have the original, which is only called Raspberry Pi Pico, and then you have a version called Raspberry Pi Pico H. This version is equal to the ordinary Raspberry Pi Pico, but it has a pre-soldered header pins included, which makes it easy to connect it to a breadboard. Then we have 2 versions of Raspberry Pi that has Wi-Fi included, namely the Raspberry Pi Pico W and then Raspberry Pi Pico WH, and this H means it has a pre-soldered header pins included. So either I recommend this one, but of course if you need Wi-Fi or internet access, I recommend this one, especially if you are going to connect and use a breadboard. So here you see some different versions of the Raspberry Pi Pico hardware. Here you see the original Raspberry Pi Pico hardware or device. Then you have the one with the header pins included. So this makes it so much easier to connect the Raspberry Pi to a breadboard compared to this one. If you have this one, you need to typically solder. You need to buy these pins separately, and then you need to solder them on all these pins, but here you get it included like this. And then you have the Raspberry Pi Pico with the Wi-Fi included, and then you see here for these versions you have this Wi-Fi chip on the board that is missing on the original Raspberry Pi Pico. And let's give a short comparison with Arduino. So as mentioned, Raspberry Pi Pico can be more comparable with an Arduino than the original Raspberry Pi. So here you see the original Raspberry Pi. Here you see the Raspberry Pi Pico, which is smaller than the original Raspberry Pi. This is the Raspberry Pi, the original one is basically a small computer where you can run a version of Linux. You can install any kind of software, etc. Basically it's a small computer which you can connect to a monitor, mouse, keyboard, etc. While this Raspberry Pi Pico is what we call a microcontroller. It's a small device which is more similar to the Arduino Uno and other Arduinos in Arduino family, where you have connectors that you can connect to external components like temperature sensors, external LEDs, resistors, etc. For the original Raspberry Pi, you can, as mentioned, install Linux as an operating system, and then you can use any kind of programming languages like the full version of Python, etc. While for the Raspberry Pi Pico, you need to use a smaller version of Python called MicroPython, which is a version of Python that is specially made for microcontrollers. For the Raspberry Pi Pico, you can also use C and C or C++. And also for the Arduino, you typically use the Arduino integrated environment and the C and C++ programming environment. So Raspberry Pi Pico is very small. It has a micro USB port which you can use to connect it to a computer or use as a power supply. It has some memory, but more interesting, it has these 26 general purpose input-output pins, including 3 analog inputs, which you can use to connect different components like external sensors, LEDs, etc. And also it has these SPI and I2C interfaces, and of course it has also pulse width modulation. Here you see the pins on the Raspberry Pi Pico. So it has 20 pins on the left side and 20 pins on the right side. In total 40 different pins, and those are, most of them are general purpose input output pins which you can use to connect sensors, LEDs, push buttons, potentiometers, etc. But it has also pins for grounds. Here you have ground here, here, here and here, etc. And you also have 3.3 voltage output, which you need in many cases when you want to connect some external components like temperature sensors, etc. And it also has pins for SPI and I2C communication. In this tutorial and in many other tutorials I will make for the Raspberry Pi Pico device, I will use the Thonny Python editor. So the Thonny Python editor is very simple to use and it's user friendly. It's cross-platform. You can use it on Windows, Mac OS and Linux, and best of all it's free, so you can just go to the home page of the Thonny and just download it and install it. So here you see the Thonny Python editor, and also the good thing with this editor, it has a built-in support for the Raspberry Pi Pico hardware. Next, when you have installed the Thonny Python editor, you need to install the MicroPython software on the Raspberry Pi Pico. So basically MicroPython is a downscaled version of Python, and it's typically used for microcontrollers and systems that has low memory, etc. like this Raspberry Pi Pico, etc. So the first time you are going to use Raspberry Pi Pico, you need to install the MicroPython firmware on the Raspberry Pi Pico, and you can either install it from from the Thonny editor, or you can install it manually. In order to install it manually, you just need to download the MicroPython UF2 file, which you find here. Just download it to your computer, and then you need to click on the button, the boot cell button on the Raspberry Pi Pico hardware, and then plug the device into your computer using the USB cable, and then you can just drag and drop this file that you have downloaded to the Raspberry Pi Pico hardware. So that's one option. The second option is to install it using the Thonny editor, and I guess that's the recommended option, because then you just open the Thonny editor, and then either here in the bottom or go to Tools and Thonny Options and select Interpreter, and then you just select the MicroPython and the Raspberry Pi Pico edition, and then you just click here, install or update the MicroPython. So now let's see how we can install MicroPython on the Raspberry Pi Pico hardware. So then I can just hold the boot cell button, connect the device using the USB cable to my computer, and this pops up. So basically, now in this mode, Raspberry Pi Pico simulates ordinary USB pin, USB device, basically a USB memory stick, and then you can download this MicroPython file. I have downloaded it here, and let's download it. So here I am on the home page of the Raspberry Pi documentation and MicroPython microcontrollers. Then here you see how you can just drag and drop this MicroPython file into your Raspberry Pi Pico device. So here you find a location where you can download it. So just, if you're using the ordinary Raspberry Pi Pico, you use this one. If you use the Raspberry Pi Pico with Wi-Fi, you use this one. I have the ordinary one, so I click on this one, and the file is now downloaded to my hard drive, and then basically I can just drag it to the Raspberry Pi device like this, and then you have MicroPython installed on your microcontroller. Or the second option is to use this Thonny editor, which you have here, and then you can either go here in the bottom, select install MicroPython, or you can go to Tools, Options, and then Interpreter. Then you select what kind of interpreter should Thonny use for this, and then you just select MicroPython, Raspberry Pi Pico, and then port. Try to detect the port automatically, and then click on this button, install or update MicroPython. And then it will take some time in order to install this MicroPython on your Raspberry Pi. So then this pops up, then you select target volume, Raspberry Pi RP2, which is our Raspberry Pi Pico hardware MicroPython variant, then Raspberry Pi Pico if you use the original one, or this one if you use the edition with Wi-Fi included. I have this one, so then I just select the latest version, click install, and then Thonny starts to install the latest version of MicroPython on the device, and then it's done. Just click close, and OK. And now I have MicroPython installed on my Raspberry Pi, and the COM port is COM8. So basically now we are ready to start using our Raspberry Pi device and the MicroPython and the Thonny editor. Then I can just start by creating a simple program, print hello or something. Basically now your Raspberry Pi Pico device is up and running with the MicroPython version of Python. You can also use, so here you have the shell, which you can use to enter one command at a time, or here you have the script editor, which you can use in order to create your Python program. So also here I can type print hello like this, and then I can just run the script by clicking the run button. And now the script is running. I can also click save here, and then you are asked to either save this script on your computer or on the Raspberry Pi Pico device. So typically you can save it to your computer, because then you have all your programs located on your computer. But in some special situations you also need to put the scripts or the Python applications directly on the Raspberry Pi Pico. It depends if you want to have the computer connected or not. So then let's start with some MicroPython examples. Let's start to see how we can program the onboard LED that is on the Raspberry Pi Pico hardware. So here you see some part of the Raspberry Pi Pico. On top of this device you see a small LED which you can program using MicroPython. So here you see a basic example how you can do that. In order to use the different pins and the built-in or the onboard LED, you need to import the machine Python library, and then you need to specify which pin that you are going to use. For this Raspberry Pi Pico, this onboard LED is defined to be pin 25. So then next is to define if this pin is an input or an output, and this should be an output. So then we just need to initialize this LED by using machine.pin, and this pin is a class that is part of the machine Python library. Then you just select the pin number, which is 25, and then use machine.pin.out if it should be an output. And then you just use LED.value and set it to either 1. If the value is 1, the LED turns on. If the value is 0, the LED turns off. So let's make this simple program and see how it works. So now we are in our Thonny editor. Let's start creating our program. So then we need to import this machine library, then define the pin, and in this case this onboard LED is pin 25. Information about that you find in the documentation of the Raspberry Pi Pico hardware, and then you just need to initialize the LED and the pin, and then just use machine.pin, and the pin is the class that handles all the details regarding the different pins. And then I just specify the first input to this one is the pin, which I have here, pin 25, and then I need to specify it if it should be an input or an output, and in this case it should be an output like this. And then I can just type LED.value and then specify either 0 or 1. If I set it to 1, this simple program should now turn on the onboard LED on the Raspberry Pi. So now if you have your Raspberry Pi Pico connected to your computer, you should see that this small LED is turning on, and if you change this to 0, run the program once more, then the LED should turn off. So basically this is a very simple application where we use the Thonny editor and the MicroPython version of Python in order to control the built-in or the onboard LED on the Raspberry Pi Pico. You can also use other functions. So instead of value, we can use a function called toggle, like this. And then basically this toggle or switch the LED either on or off. So now my LED is off. When I run it now, the LED will be on. When I run it once more, the LED will be off. So then by clicking the run button, it will turn the LED either on or off based on the previous value. So that's the toggle function. The next step now would be to create a while loop where you can turn the LED on and off inside this while loop. So then let's create a simple while loop. So then I just type while true like this. This is a while loop that goes forever. And then I can just move this toggle function inside the while loop like this. And typically also when you have a while loop, you also want to have use a sleep function. So then I can import time library. And then here inside the while loop I can just use time dot sleep and then specify a number of seconds like this. So I can specify 2 seconds or something. So basically now we have imported the libraries that we need. We have initialized the LED and the pin, and inside the while loop we toggle or turn the LED on and off, and it has a wait here or a sleep. So then when it turns on for 2 seconds, and then it goes in the loop once more time and toggle or turn the LED off, sleep for 2 seconds, and then it goes like this forever. So then you can just run the application. Yeah, it was of course a spelling mistake there. There should be a small like this. So while true, then let's just run it. And now I should see on my Raspberry Pi Pico hardware that this onboard LED is turning on for 2 seconds and then turning off for 2 seconds, turning on, off, etc. And also instead of the toggle I can also use this value like this value. So I can first turn it on, sleep for 2 seconds, then I can turn it off like this and sleep for 2 seconds. So this is this program will behave in the same manner that was using this toggle function. So it turns on for 2 seconds and turns it off for 2 seconds. It goes into a new iteration, turns it on, off, etc. So in this example I have imported the entire machine library. I could also have done like this. So from machine import pin. So in this case I only import the pin part of the machine library, and then I can change the code like this. So then since I'm importing the pin only, I don't need this machine, so I can just do like this and run it. So it will be the same, but by using this instead I'm only importing the part of the machine library that I will need in this application, so it will save space on the Raspberry Pi Pico hardware. There's also another way to turn this LED on and off. I can also use the built-in timer class, which is included in the machine library. So then I can define a timer. Timer equals to timer like this. Then I can define a function. I can call it blink or something, and then inside that I need this timer, and then I can use this LED toggle like this, and then instead of this while loop I can just use timer init, and then a frequency, then I set it to 1 second. Mode equals to timer, and it should go periodic like this, and it should have a so-called call back function, which is this function we have created here, this blink function. So basically this is the same, this program will have the same behavior as the previous one, but here I have used the built-in timer functionality instead of a while true loop. So let's just run it, and then the program will have the same behavior. Now the blink or the LED will turn on and off every second. I can change it, of course, to 2 seconds, 3 seconds, 5 seconds, etc. And since this is frequency, I can set 0.5 and then run it, and then the LED will turn on for 2 seconds, turn off for 2 seconds, etc. So it's up to you if you want to use this timer feature or a while true, or in some cases a combination of those. So basically this is how you use the onboard LED on the Raspberry Pi Pico. Here you see the onboard LED example is running. Then you see the built-in or onboard LED is turning on for 2 seconds, off for 2 seconds, on for 2 seconds, etc. So now we have used the onboard LED. Let's see how we can use an external LED instead. So here you see an example of a wiring using an external LED. So here I have used a breadboard. I'm connecting a LED, and then I'm connecting or using one of the pins on the Raspberry Pi Pico. You can use any of those green pins. I have just chosen to use pin number 16, which is this one. Then I connected this one to the LED, and then it goes through a resistor. I'm using a resistor in order to not destroy the LED, because if the current through this circuit is too high, the LED can be destroyed. So then I just using a small resistor. It could be 270 ohm, it could be 330 or something. Just use a resistor that you have. It just need to be a small resistor in order to limit the current in the circuit. So then when I turn these pins on, the current will flow here through the resistor, through the pin, and back to one of the ground pin like this. And then we will create a simple program that turns these LEDs on or off, similar to that we use this built-in LED that is on board here. But in our case, we have an external LED that we have connected on a breadboard. So in order to find a resistor, you can of course use a multimeter in order to measure the resistance through the resistor, or you can find a resistor calculator on the internet and see these different colors in order to find the correct resistor to use in this application. So now we are back in the Thonny editor. Here is one of the previous examples we made. So this example turns the built-in LED either on or off, and the built-in or the onboard LED has pin 25, while now we have connected an external LED to pin number 16. So then we just change it to pin 16, and then we can run the application. And here I now see on my breadboard where I have connected the external LED, it turns on for 2 seconds, then it turns off for 2 seconds, and then it turns on, off, etc. So basically the program is the same. I just needed to change the pin number because now I've used one of the one other pin of the Raspberry Pi Pico hardware. So basically this is the simple program to turn an external LED either on and off, and here I have used this value 1 and value 0. You could use this toggle function, or you could also have used this timer feature instead of this while loop. So here we see the LED is connected to the Raspberry Pi hardware, and we are using our resistor in order to limit the current that's flowing through the circuit. And then you see the LED is turning on for 2 seconds, then turning off for 2 seconds, on, off, etc. until we close down or shut down the program. Now we will use something called pulse width modulation with a Raspberry Pi Pico. So far we have seen how we can turn a LED either on or off, but now we want to control the brightness of the LED. Typically can use that. You can control a brightness of a LED using something called digital to analog converter, but the Raspberry Pi Pico doesn't have a digital to analog converter, so we need to use a technique called pulse width modulation. So basically we are controlling the amount of time that the LED is on versus off. And this technique is called or known as pulse width modulation. So here we see the principle of this pulse width modulation and how we can control the brightness of a LED. So basically we control the pulses, and these pulses are either on or off, and the longer the pulses are on, you see the brightness is higher than when the pulses are mostly off, like it is. With the Raspberry Pi Pico, it has a 16-bit interface. This means we have 65,536 different levels, or basically we can control the levels from 0 to 65,535. Here you see 3 specific examples. So the upper example here, so the pulses can be either 0 or 3.3 voltages. So we have low and high, and in this case the amount of pulses where they are high are 10%, and amount of pulses that are low is 90%. So this means we have an average of 0.33 voltage, and this means the lightness or the brightness of the LED will be low, while here in the middle we have 50% low and 50% high, and then if you calculate the average we get 1.65 voltage out of 3.3 voltage, and then you see we get a higher brightness. And finally in this example we have 90% high and then 10% low, and then you see the average will become 2.97 voltage, and then you see we get a higher brightness. So basically this is the basic principles of pulse width modulation. So let's see how we can use Python or MicroPython in order to control the brightness of a LED. So here you see a basic example. So in order to use pulse width modulation we need to use the PWM class of the machine library. So basically from machine import pin and pulse width modulation. So then we need to define the pin you are going to use. I'm using the same pin. The wiring will be the same, so we use this external LED that we have wired and connected to the Raspberry Pi Pico using a breadboard, and then we use the pulse width modulation class and then just define the pin that you are going to use. You need to specify the frequency, so then you just use the default frequency, which is 1000. And as mentioned, we can have 65,536 different levels of brightness from 0 to 65,535. And then here I'm just creating a basic for loop that are going through these it starts on 0 and increases the brightness until it reaches 65,535. So then when we run this application, we will see the brightness of the LED will be increasing step by step. So let's go to Thonny and implement this application. So here we are back in Thonny, and this is the previous example that was turning the LED either on or off. So just use this as a foundation for our next program. So then we need also to include this PWM. We use the same pin, and instead of the LED we just need to use the pulse width modulation class. So pulse width modulation, and then pin, and the pin we have specified here, like this. So then we shall now use pulse width modulation on pin 16, which is the previous wire diagram where we wired the LED on a breadboard. So then here, instead of this while loop, we just use a for loop. So then I specify this number of levels, which is 65,535, and then we create this for loop for, and then we can define these brightness levels. Brightness, and here this is just a variable. It could be X or whatever in range of n, like this. So this is the for loop, and then we need to use this pulse width modulation object we created and use the function called duty U16, and then input to this one is this level of brightness that goes from 0 to 65,535. And also we use a sleep function, and then since this for loop is it has many iterations, so we don't use a long sleep period, so we can use 0.0001 second or something like this. And then also finally we can turn the LED off when we are finished, just by setting the brightness level to be 0, like this. So basically this is the entire program for using pulse width modulation, and when we run it now, yes, I just need to specify time here, time.sleep, run it, and now when you run it, the level or the brightness of this LED will increase step by step. We can also increase the sleeping a bit, so we see it clearer when this bright level is increasing on the LED. But basically this is the basic principle to control the brightness level of a LED using so-called pulse width modulation. Here we see a demonstration of this pulse width modulation. So now when I turn on the program, you will see that the LED will increase step by step. It will take a couple of seconds going from 0 to this 65,535 level. So then now I will click on the run button and then observe the LED, and you see it is the level of the LED was increasing step by step. Let's run it once more, and you see the LED was increasing, and finally I just shut it down in the end of the program. Now I will show how you can use an external temperature sensor and connect it to the Raspberry Pi Pico. The temperature sensor is a TMP36 temperature sensor. Here you see the TMP36 temperature sensor is very small, easy to use, it's cheap, and it has 3 pins that you wire and connect to the Raspberry Pi Pico. Typically you mount it on a breadboard and then wire it to the Raspberry Pi Pico. In order to read values from this sensor, you need to be able to read an analog voltage using the Raspberry Pi Pico, and luckily Raspberry Pi Pico has 3 analog to digital converters that we can use. So here you see the 3 ADCs that are on the Raspberry Pi Pico. You have ADC 0, which is pin 26, and then you have ADC 1, which is pin 27, and then you have ADC 2, which is pin 28. So you can use any of these 3 pins in order to connect this temperature sensor or similar components to the Raspberry Pi Pico. Basically, this is an example how you can wire the temp 36 to the Raspberry Pi Pico. So then you need this 3.3 voltage, which is connected to the first pin, and the third pin is a ground, which you use one of the ground pins. I just use this one. You can of course use this one, this one, this one, this one, etc. And finally, the pin in the middle is the analog voltage output from the sensor, which need to be connected to one of these analog to digital converters. So I choose to use ADC 0, which is on pin 26. So the analog to digital converter, or the ADC on Pico, is a 16-bit. It means it produces values from 0 to 65,535. We use the MicroPython function read_u16 in order to read the analog input value, which then will be a value between 0 and 65,535. Typically you want to convert this value, which is between 0 and 65,535, to a voltage value, which is from 0 to 3.3 voltage, which is the maximum voltage level on the Raspberry Pi Pico. And then basically this is a linear scaling using a linear equation like this. So then basically this is the linear formula for converting from x, which is between 0 and 65,535, to y, which is the value in voltage between 0 and 3.3 voltage. So that's how we convert from the pure ADC value to the voltage value inside our application. Next, we need to convert this voltage value to a value in degrees Celsius. And then if we look up in the data sheet on this temp 36 temperature sensor, you will find this figure. And this figure gives an overview of the relationship between the voltage that are given from the sensor and the temperature in degrees Celsius. And basically, for this temp 36, which is B, which is this line, basically it's a linear relationship between the voltage level and the level in degrees Celsius. And then, since we can use or find 2 values or points on this line, so I use x when x1 is 0.75, which is basically here. Then we have 25 degrees Celsius, and then it's 1 voltage, which is here. We have 50 degrees Celsius. So we use these 2 points, and then we can use this formula we have here for finding the linear relationship between the voltage and the temperature in degrees Celsius. And then we end up with this basic formula where x is the output, the voltage level, and y is the temperature in degrees Celsius. So basically, first we need to find the voltage value, then we need to convert the voltage value to degrees Celsius, and then basically we end up with the following program. We need to use the machine library, and then we need to import the ADC class of the machine library. We need to specify the pin we are using, and according to this wiring we are using pin 26. And then we just create an object of this ADC class where we specify the pin number, and then inside a while loop we start by reading the ADC value, which is between 0 and 65,535. Then we convert it to voltage between 0 and 3.3 voltage, and then we use this formula in order to convert it to degrees Celsius, and then we can just print the value to the screen using the print command. So let's go to our Thonny editor in order to implement this application. So then let's start creating the application. So we need to import this ADC from the machine library. We define pin 26, and then we just start to define this temp 36 sensor using this ADC class, and then we just specify the pin like this, which we specify here, which is 26, and then inside the while loop we just start by reading the ADC value using this temp 36 object point and this read u16 function like this, and then we convert it to a voltage value using this formula 3.3 divided by the number of levels, which is 65,535, multiply with this EDC value like this. So now we get the voltage level. Now we need to find the degrees Celsius value like this, and then we use this formula 100 divided by the voltage level minus 50 like this, and then we can just print it like this. And typically we need to have a sleep, so then I just read a new value, let's say every 5 seconds or something, and then we can just run it. Yeah, was some spelling mistake there, from time import sleep. So now we can run it. Let me see, should be a degree C like this, and now you see this is actual temperature value in degrees Celsius, and we read a new value from the sensor every 5 seconds. Then we can also, here's a lots of number of decimals because the accuracy of this sensor isn't that accurate, so then we can just use this built-in round function to limit the number of decimals like this. So let's just run it once more. Round. So now we get the temperature 26.4, 26.7. Now I can hold the fingertips on the sensor, and hopefully also you will see that the temperature will be increased. So now it's 29.5, 30.6, etc. So basically this is how you connect a temp 36 temperature sensor to the Raspberry Pi Pico, and then create this simple program in order to be able to read the temperature value from this sensor. So now we have seen how we can program the Raspberry Pi Pico using the Thonny editor and the MicroPython environment. So far we have been connecting the Raspberry Pi Pico to our computer using the Thonny editor, but you can also run your application without having the PC connected to the Raspberry Pi Pico. So basically the application you create, you typically just name it main.py and then save this file to the Raspberry Pi Pico hardware, and then you can unplug the Raspberry Pi Pico from your PC and then just use an ordinary power supply, typically between 1.8 voltage and 5.5 voltage, and then the program will, when you plug in the power supply, this main.py program will start to run automatically. So basically this is how we can run the software or the application that you create on your Raspberry Pi Pico without having a PC connected. You can also use another library than the machine library. There is a library called Pico 0, which is basically another library that you can use instead of the machine library. Typically this Pico 0 Python library is intended for beginners, but basically it has the same features as the machine library, but it has some simplified functions that can be handy to use for beginners. But basically you need to include or install this library on your Raspberry Pi Pico. So basically you go to your Thonny editor and go to the package manage packages, and then just search for Pico 0, and then when you find it you just install it. And when you have installed it, you can, instead of the machine library, you can use the import the Pico 0. So here is a simple example how you can turn this LED on and off using the Pico 0 library instead of the machine library. But basically the program is more or less similar, but you use the Pico 0 library instead of the machine library. Basically the main difference here is using LED.on and .off instead of value equals to 1 or equals to 0. But basically the principle is the same, but the name of the function and the behavior is a little bit different. Here you find some external resources that you can use in order to take the next step when it comes to Raspberry Pi Pico. You have the Raspberry Pi Pico overview of the Raspberry Pi Pico or the Raspberry Pi homepage. You have the Raspberry Pi Foundation. Here's our getting started with Pico, and then here you have an overview of the MicroPython library. You will also find lots of resources regarding Raspberry Pi Pico on my homepage, so just go to halvorsen.blog, that's my homepage, and select the menu here, select technology, and then select Raspberry Pi Pico, and then you will come to the homepage of my Raspberry Pi Pico resources. So here you will find information about the Raspberry Pi Pico. You will find lots of resources, tutorials, videos, etc. So basically just click on the link that you are interested in, and then you will come to a new page where you get details, a detailed overview of the topic. And basically this is the getting started with the Raspberry Pi Pico. Here you can see the video that we just was going through now. Here's the PowerPoint. Here are the different examples that we was going through. Here is the blinking onboard LED. Here is the blinking external LED. Here is the pulse width modulation example. And finally here is the temp36 temperature sensor example, etc. So that's all, so good luck with the Raspberry Pi Pico. Thank you and goodbye.